In 2023, an ambitious project known as BrainNet demonstrated a new frontier in communication, allowing users to share thoughts directly over the internet via brain-computer interfaces. Imagine a world where individuals can convey complex ideas without uttering a single word. This capability, once confined to the realm of science fiction, is now becoming a reality. The implications of such technology are vast, raising questions about how we will interact with one another and the very nature of communication itself. This represents a paradigm shift, where thoughts are no longer tethered to words, unlocking unprecedented avenues for collaboration and creativity. The technology behind BrainNet relies on advanced neural decoding algorithms, which interpret electrical signals from the brain and translate them into actionable data. This has been made possible by the convergence of neural engineering, artificial intelligence, and machine learning. As researchers at universities like the University of California and companies like Neuralink refine these techniques, the metrics of accuracy and response time are improving rapidly. The roots of brain-computer interface technology extend back to the early 2000s, with the groundwork laid by pioneers like Miguel Nicolis, who first demonstrated the ability of monkeys to control a robotic arm using brain signals. By 2013, advancements in neuroimaging and signal processing allowed scientists to not only interpret simpler thoughts, but also to elaborate on complex sequences of intent. Fast forward to 2020, and we witnessed the inception of prototype systems like the ones developed by Neuralink, which emphasized miniaturization and biocompatibility. A scene unfolds at one of their research facilities. Scientists clad in lab coats peer intently at screens displaying intricate waveforms, the hum of machinery punctuating their discussions. A sense of urgency hangs in the air as the potential for a new communication medium becomes palpable. The BrainNet project itself involved a collaborative effort between neuroscientists, engineers, and ethicists, driven by a singular vision: to bridge the gaps that words can sometimes create. As users donned their headsets, a rush of excitement and trepidation filled the room. One participant, a young researcher named Alex, recalled, "I felt like I was stepping into a realm I had only dreamed of. The moment I shared my thoughts with my partner across the room without saying a word, it changed everything for me." The experience was surreal, as the participants navigated through an unseen network of ideas, feeling the ebb and flow of thoughts merge seamlessly. Early trials have achieved a decoding accuracy of over 70%, a significant leap from earlier models. This was not just a number. It represented countless hours of painstaking research, trial and error, and unyielding perseverance. However, the road ahead is fraught with challenges, including refining the interfaces for widespread use, ensuring user safety, and addressing ethical considerations surrounding privacy and autonomy in thought sharing. Imagine a potential future where someone's innermost thoughts could inadvertently be broadcasted to the world. The ethical implications are staggering. Looking to the future, the potential applications of brain-computer interfaces extend far beyond simple communication. Industries like healthcare could see revolutionary advancements, with BCIs offering new ways to treat neurological disorders and enhance cognitive function. Think of the possibilities: stroke survivors regaining the ability to communicate through thought, patients with ALS controlling their environments through mere mental commands. In one moving case study, a patient named Sarah, who had lost her ability to speak due to a severe stroke, was able to articulate her thoughts using a BCI system. As she shared her first coherent message with her family, tears streamed down her face, and the room filled with a sense of hope and healing. Imagine a world where individuals with physical disabilities can control prosthetic limbs merely through thought. The thought of someone, paralyzed for years, now grasping a glass of water on their own is both profound and humbling. Furthermore, as these interfaces become integrated into our daily lives, they will shape how we learn, work, and connect with others, fundamentally altering societal structures. With BCIs, education could transform dramatically. Students could learn languages by directly downloading information to their brains or collaborating on projects in real time without the barriers of verbal communication. Yet, as we stand on the precipice of this new technological era, it is crucial to critically examine the ethical landscape. Questions arise about access. Will these transformative technologies be available to all, or will they be reserved for the privileged few? As enhancements become commonplace, How do we ensure that they do not widen the existing gap between those who have access to such technologies and those who do not? It is an urgent conversation that must be had as we collectively navigate the future. As we look ahead, how will these innovations redefine what it means to be human in the next 5 years? Will we embrace this new form of connection, or will we retreat from the vulnerability that comes with sharing our thoughts so intimately? As the lines between our minds and machines blur, we find ourselves at a crossroads in the evolution of communication, questioning not only the mechanisms of our interactions, but the very essence of understanding itself. The future beckons, and it is up to us to shape it thoughtfully.